So prior to getting started within Hero, it is good to have familiarity with your building to know what you're about to model so you don't do any mistakes. So I'll just review the plans with you quite quickly. Here we have a relatively simple single level residential dwelling. It's a monopitch roof. We have a site plan. There's no fences shown or adjacent dwellings, so as per technical guide notes, given this does look like a kind of suburban allotment, we do need to model those fences and adjacent buildings that would be a reflection of this onto the northeast, south and west side of the dwelling in terms of screens. You'll notice I've added a few dimensions to these plans just to save us time as we do this tutorial, just so I can know the screen projections that we're going to need to enter manually. This is our main floor plan on sheet number 3. This is what I'll want to be importing into Hero. It's 1:100 at A3. You can see here in the plans we have a large dining living room space, a study space, entry with permanent openings off that open plan space, some bedrooms here, garage and utilities on the south. Relatively well done passive design given that our north arrow is facing directly up. You'll see here we see some notes here about a rake ceiling or a pitched ceiling through this dining living room section, whereas this kitchen has a ceiling height of 2400. So this dotted line here is where we'll make our split on the ceiling and split these two ceilings apart so we can change their properties. You'll see the rest of the utility spaces all are 2400 ceiling, except the garage 2486. It's got an 86mm step down, so its ceiling height will be the same, but its bottom of its walls will be lower. And then the front bedrooms are 2780, as well as this entry space. So we're going to have to think about the differences in ceiling heights in terms of how they create any floating walls adjacent to roof spaces, etc. You can also see here inside this internal space that we've got some different types of wall materials in here. Most of these are stud wall materials, but these spaces here do look like they've got brick. We'd want to be modelling that within the internal walls as well. Moving through, we can see our north elevation here. We've got some highlight windows above the main sliding doors. We'll just model those over the top of each other. East elevation, south elevation, we've got a few different wall types here that we'll have to pick up when we get to that. Our west elevation, section through here. You can see this drop-down ceiling section in the kitchen for the bulkhead, and as well as some of these indications that we're going to need to start modelling some of these floating walls that are adjacent to the roof space. Here we see that internal wall type in the kitchen, living, dining area, open plan space, and it's adjacent to roof space portion as well, and some further dimensions here that we'll need when we start adding those floating walls. You can see here we've got some slab edge insulation on our slab, it looks like. This is the little entry alcove. We'll need to be modelling a lot of these walls as screens, eaves and wing walls. So just dimensioning a couple of those ready for our assessment. Our wall type schedules, as well as the internal walls, floor and ceiling and roof type schedules, and a window schedule, door schedule, floor coverings and electrical plan, showing we've got some downlights, recessed downlights and ceiling fans. So we can leave auto penetrations on as a setting within Hero. First things first, bring in the plan. We know it's page number 3. It was an A3 drawing. Hero's picked it up as A3. That can sometimes change if the designer's printed it out differently, so we do need to check that. Scale was 1:100. Always worth doing a check measure just to make sure we've got everything right. That's perfect. I like to put in the level heights straight away. That's 0.25. We saw on the elevation. The ground level here compared to the floor level is 0.25 meters. And we'll save off this file just so that we can use the quick save Control S feature as we move through the model. Just making sure that we're saving as we go through. Alright, so we'll start with zone drawing. I'm just going to toggle between the line and rectangle submodes by using the keyboard shortcut tilde most of the time, so I don't need to go up and click that button there. And you can see those alignment lines start to pick up existing points that we've used within the model straight away. We can see here we have a couple of walls that have come in and have not been picked up as these adjacent to stud null adjacency sections. You can see here they've been drawn in, they've not picked up the adjacency correctly. So we recommend these just get modeled as a neighboring adjacency so that no heat transfers modeled out of them and that they don't pick up wing walls, etc. We'll be improving that detection to try and eliminate this, but for now we change those to neighboring. We've done our zones. We then step through and do our windows, starting with the original window 1, just so that we're naming our windows according to the window schedule. We've got these highlight windows over the top, so window 4, 5 are the lower ones, window 6, 7 are the highlight ones. We're also going to come back through and split many of these windows as they actually, as you can see here on this window 14, actually has 3 segments, 2 openable sections and 1 fixed. And so we'll come back and we'll split these up, but it's going to have the correct name that all the split windows will get split off. So it helps to draw the windows in their window schedule numbering if you've got it. Got our external doors, door number 1, door number 2. Moving through to internal doors, I like to put in then widths if they are shown on the plans like they are here. They're all 2040 high, but their widths are a little bit different across here. We're just typing here the dimensions, and that will be the true width within the data grid too. Let's move to permanent openings. 1500 hallway opening. Got our permanent opening here, and there was one more between the bedroom and the walk-in robe. Okay, that's our permanent openings. I'm going to move this exhaust fan over into the kitchen. Next step on our workflow typically is holes or stairwells. There's none of these on this project, so we can ignore that. Skylights. Again, no skylights or roof windows on this project, so we can move to eaves. You can see here our main eaves that we want to draw in are this veranda area. This dotted line shows the alcove, entry alcove, and we also have an eave over this south face here. So let's grab these walls. That just means that they're all connected prior. It's a faster way of drawing eaves in. This wall also has an eave going that way, and likewise this wall has an eave going that way. And for the entry, we'll do the same. This wall has this eave, this wall has this eave. Okay, that's our eaves drawn in. We're now at screens. Shading each other is what we check first. So this wall will be shaded by a screen here. This wall will be shaded by a screen here. This wall actually also has a second screen along this edge here. It's a different height to this wall. So those are our screen walls within the dwelling. We'll be trying to pick these up automatically in Hero in coming versions, but for now, like the other tools, you do need to enter these in manually. If we go back to our site plan, we also want to model our fences. I mean, a lot of plans would have the fences shown on the floor plan. This is kind of just floating, and we'll fix those dimensions up in terms of where they truly are. When we get to the data grid and we start looking at projections off those kind of things, let's just roughly get them in, clean them up later. We also have to put in kind of a reflected building onto the north, east and south. So again, we'll just quickly select those walls. It's going to be the same distance away from the fence as our dwelling is, and we'll just model it as a single screen, capturing the ridge height closest to us on a similar floor plan. This one's quite a way away. We've got a footpath and then a road, and then you'd assume another footpath and then another fence. So it's going to be some fair way up across here. Likely not to have much impact on the model at all. Alright, so that's our screens drawn in. In terms of visual items, next step we'll just walk through double checking our wing walls. These are obviously picked up the fences as wing walls, which is correct, but we've got some closer wing walls for this north eave that are going to have more impact as we would judge it in terms of shading than a fence. So we just drag those wing walls back in. It's always worth checking the automatic wing walls that are picked up just to make sure they're all sensible. It's picked up the fences there for all the south facing walls here, the wing wall, that's been picked up correctly. We're happy with that. We might, for these tight dimensions, we might want to override these wing wall dimensions as they are calculating off the inside edge of the wall. We'll improve that in a future version of Hero so that it's the outer face of the wall, but if you wanted to clean up some of those calculation dimensions of those wing walls, you can override those automatic wing walls. This wall here has a wing wall that pushes out along that screen, and even this wall here should pick up that left wing wall there too. The garage, it's picked up that screen there, and we'll override its left there. As per many features within Hero, there are a few ways to do things, and as we progress towards full automatic shade detection, there will be changes to the way you need to model screens, eaves, and wing walls. For this example, an alternative method to setting the wing walls as a manual overridden wing wall along this northern veranda would have been to actually just create some screens to the left and right of this veranda. So I'll draw those in, and then I'm going to just set the manually overridden property of those manual wing walls that we entered back to automatic so they can recalculate their automatic positions again. So we can now see that we've got those screens picked up as the left and right wing walls automatically for these north walls, and we could also do the same for the garage there. We just need to then set the height of that screen within the screen data grid, and that will update the wing wall vertical offset height. So again, we're evolving this feature so it'll be more seamless, but you'd probably agree that where we're going with this will likely be a better way of modeling wing walls than our standard approach. It will just give the flexibility to remain in automatic wing wall mode most of the time. Alright, so we're done on the wing walls there. Next we generally do penetrations, so let's flick to the electrical plan. Ceiling fans across here. In terms of downlights, we might do this as an example within the data grid, just using the numbers column, as all of the zones have downlight within them. So we'll leave that there. We'll just make sure we've got the exhaust fan in these two baths, and given that that was the first zone created, it's the kitchen, it's already been populated with an exhaust fan, which is that range hood. So that's penetrations done. Moving through, the next item on our workflow is splitting of objects. We need to now split this ceiling space, so let's change to split drawing mode. We want to make sure we're splitting ceilings only. If we did split the floors, that wouldn't be a big deal. We could merge them back together, just leave them as is. So here we're in ceiling visual mode. We can see here we've now got two ceilings within this zone. One of them will turn into a flat roof and one of them will have the roof space connection. Moving on from splitting polygons, we will put in the floating walls that we'll need to model for roof space adjacencies or any other adjacencies you might need for different level objects. This garage is a drop down, but it's a 86mm drop down, meaning in the elevation here, the adjacency of that 86mm drop down is to another floor. In Chenath, it's 2D flows. We can't flow into the side of an object. It's similar to how within Hero we remove these style of adjacencies which are coming in the side of an element. We do the same for the garage drop down there, so that 86mm is ignored in a Chenath simulation. The other walls that we're going to need though are the internal floating walls over certain areas, so we'll need one over the ceiling, we'll need some between this internal wall and the roof space here, this section here too. We'll need the 2400 ceiling spaces with the 2780 ceiling spaces, having a wall there between bed 1 and hall, which will also be the same for our garages. So let's move to floating wall drawing mode, and we've got one big floating wall here over that bulkhead. We'll have another wall here, given that this rake ceiling section goes to the top. There'll also be a different height floating wall there between the pitched roof and the hall, and likewise between the pitched section and the 2780 entry. We'll have floating walls having a roof space adjacency through here. We'll also have one more across here. So it can be best to select those floating walls. These are all floating walls that are adjacent to roof space. So to make it easier to see them in the data grid, let's give them their adjacency now. They're adjacent to a roof space. So we go to the wall data grid, adjacency column, roof space. These are now all adjacent to the roof space. And now within the data grid, we can kind of find these walls quite easily because they're all going to be the RSW types. The last thing we want to add here is, in this example, we've got a tiny little nib wall here. This is actually can be modeled as an internal thermal mass element. It is a piece of brick, so why not? And so we'll change its adjacency to mass wall here in the data grid, so we know that that's that particular wall. We can review our model now. This is looking pretty complete from a visual perspective, and from here we can move to the data grid and start to work through and tidy up the complexities.